All right, we're going to work on our third and final example problem. This problem is going to be this one over here. It's going to be slide and divide. So slide and divide means that unlike this problem where we could factor out as six small numbers, there is no number that we can factor out from a 2, a 3, and a 5. Actually, a 2, a negative 3, and a negative 5. So the method I like to do is called slide and divide. It's going to require a little bit more work, but this 2 we're going to take over here to this negative 5, and we're going to multiply it, and that's going to give us 2 times negative 5 is going to give us negative 10. So now our job are to find the factors of 10. We'll deal with the negative sign in a moment. So factors of 10 would just be 1 and 10, and then 2 and 5. 2 and 5. So we know that when we multiply these numbers together, it has to be negative. We also know when we look here that when we combine the like terms, it needs to be negative. So in that situation, we know since we're combining like terms, it has to be negative, that the bigger number has to be negative, and the smaller number needs to be positive. So that means this is positive, that means this is positive. So when we're mathematically now looking at the combinations of numbers, we need it to equal negative 3. Well, 1 minus 10 is going to give us negative 9, so that's not the number we need. If you have $2 and then you owe someone $5, you can't give them everything you need, so you're still going to be able to give them 2, but then you're still going to owe them 3. So this is the winning combination that we need. So we're going to plug those numbers in. So when we do that over here, we're going to have now x is plus 2, so this would be x plus 2. And then our other number is going to be negative 5. So we're going to now, we got to deal with this 2. So since we multiplied everything by 2, we really need to divide everything back by 2. And we haven't worked on this a whole lot. We did just a little bit of this when we were last together. So hopefully you notice that one of these is going to work. When we do this, 2 divided by 2 is going to be equal to 1. So that's what we want. So I'm going to come up here for more room. So now we're going to have up here x plus 1. And eventually that's going to be set equal to 0. But when we come over to this side, negative 5 divided by 2 is not going to give us a whole number. So we're going to now take this 2 and we're going to slide it back over here. So when we do that now, for the second part, we're going to have 2x minus 5. And that's going to be equal to 0, which is going to get a little tricky in a moment. But when we deal with the one on the left side first, the one that's going to be easier to do, what number plus 1 is going to be equal to 0? Well, that's going to be negative 1. Negative 1 plus 1 is going to be equal to 0. So this is going to be negative 1. This answer here is not going to be as clean. What we're going to need to do then is really to do this, it's going to be some number times 2 minus 5 is equal to 0. So really what we're doing is we're solving a two-step equation. So I'd really add 5 to both sides, because when I add 5 to a negative 5, it's going to make that disappear. So now what we're going to have is 2x is going to be equal to positive 5, because again, a positive 5 added to a negative 5 is going to give us 0. Then we're going to divide by 2, and then we're going to divide this by 2, which means then that the answer here is going to be 5 halves. And we'll see that in a moment when we graph it. 5 halves is also equal to 2.5 when you turn it into a decimal. So we'll come back to that in a moment. Axis of symmetry again means when we eventually graph this line, where is the bottom point of it going to be when it goes from negative to positive? So what we need to do is we need to take negative b. Well, b right now is negative 3. So we need to do the opposite of negative 3. The opposite of negative 3 is going to be positive 3. And then we're going to take our a and we're going to times it by 2. Well, our a again is the coefficient in front of the x squared, which is 2. And we need to take the 2 and we need to times it by 2. Remember again that the a is the number in front of the x squared. The b again is the number in front of the x. So when we do this on the bottom, we're going to get 2 times 2. And 2 times 2 is going to give us 4. And then we have our 3 on top. So that means that where this is going to cross on the x is going to be 3/4. Let's take a look and make sure that all this stuff that I'm saying is true when we graph it. So I'm going now here and I'm clicking on the Desmos, which should bring this up. As you notice, I've already typed in the equation here, 2x squared minus 3x minus 5. And you notice that this value here is at -1. That's going to be halfway between -2 and 0. -1 is one of the numbers that we got here. Now the other spot where it should cross should be at about 2.5. And when we notice, here is 2 and here is 4. This line here would be 3. And notice then that this line is crossing halfway between 2 and 3, which would be 2.5. So that works. The last thing we're going to take a look at now is this axis of symmetry. Hopefully it is at 3/4, which is just going to be a little bit less than 1. And when we look at the bottom here, we can tell that if this line here were to be equal to 1, which it is, draw this line down, that actually where it crosses here is going to be a little bit before that. So that is actually going to be at 3/4. That is where that location is going to be. So that shows us graphically that the numbers we mathematically found for the solutions and for the vertex are going to be accurate. Thanks for watching. If you have any questions, please again reach out to me. Thanks.